You're staring at something roughly the size of a small car. It's colder out there than anywhere on Earth, colder than the deepest trench in the ocean, colder than a winter night in Antarctica multiplied 100 times over. It's been flying through total darkness for longer than most of your parents have been alive. Right now, this thing is more than 15 billion miles away from where you're sitting. Light from the sun reaches your eyes in about 8 minutes. Light, or a radio signal moving at that same speed, takes over 23 hours just to reach this object, one way. It runs on decaying plutonium, a power source that's been quietly and visibly ticking down since before most streaming services, before the internet, before cell phones existed at all. It has outlived the engineers who first built it. It has outlived the very computer language it thinks in, a language so old that almost nobody alive today learns it in school. It has outlived the original definition of what this mission was even supposed to accomplish. And a few months ago, it sent home a signal that made grown adults, trained NASA engineers who have spent their entire careers keeping their composure, genuinely afraid they were about to lose it forever. This is Voyager 1. And what it just did out there, past the edge of everything we casually call our solar system, should make you stop and actually sit with that for a second. Because this isn't just a story about a machine drifting through space. It's a story about what happens when something built to last 4 years simply refuses to stop working after 47. Quick pause, because if you're new here, this channel exists for exactly this kind of story, the ones that sound like science fiction but are completely, verifiably real. No exaggeration, no invented drama, just the facts, told the way they actually deserve to be told. If that sounds like your kind of channel, go ahead and hit subscribe now, because there's a lot more like this coming, and you won't want to miss it. Now, back to Voyager. To understand why one strange blip from deep space had grown engineers losing sleep, you have to rewind all the way back to 1977. NASA had noticed something rare in the mechanics of the solar system. Once every 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, happen to line up in a way that lets a spacecraft slingshot from one to the next using each planet's gravity instead of burning enormous amounts of fuel. It's called a grand tour, and this kind of alignment only comes around a couple of times per millennium. So NASA built two identical probes, Voyager 1 and Voyager 2, and gave them a specific, limited job: fly past Jupiter and Saturn, take pictures, collect data, and report back to Earth. The mission was budgeted for roughly 4 years. Nobody involved in planning it seriously expected these machines to still be transmitting in the next century. Nobody expected them to leave the solar system entirely. That idea wasn't even part of the original pitch. But Voyager 1 didn't just visit Jupiter and Saturn and call it a day. As it passed Jupiter's moon Io, its cameras caught something nobody had ever documented anywhere in the solar system besides Earth: active volcanoes, mid-eruption, spewing sulfur high above the moon's surface. It was the first confirmed evidence of active volcanism on another world. Then, passing Europa, Voyager 1 photographed strange, cracked, almost fractured-looking ice on the surface, a pattern that hinted, decades before anyone could confirm it, at a liquid ocean hiding beneath that frozen shell. At Saturn, it captured the rings in a level of structure and detail nobody had ever seen from Earth-based telescopes, and it gave humanity its first close look at Titan, Saturn's massive moon, wrapped in a thick, hazy orange atmosphere unlike anything else in the solar system. And then, instead of shutting down once its planetary flybys were complete, it just kept going. Engineers slowly realized they had built something far tougher than the mission plan had ever accounted for, so they extended the mission, then extended it again. Somewhere along the way, Voyager 1 stopped being just a planetary probe and became something else entirely, a spacecraft chasing a goal nobody had written into the original paperwork: leave the solar system completely and become the first human-made object to physically enter interstellar space. That's the story most people already know, at least in outline, but none of that prepared anyone, not the engineers, not the scientists, not the public, for what came next. The first real turning point arrived quietly in 2012, though it took scientists until the following year to actually confirm it. For months, instruments on Voyager 1 recorded something strange. The density of charged particles surrounding the spacecraft had suddenly spiked, jumping to a level far higher than anything measured inside the solar system's protective bubble. But here's the twist that confused everyone at first. The direction of the surrounding magnetic field hadn't shifted at all. Scientists had expected that crossing into interstellar space would come with an obvious dramatic change in that magnetic field. It didn't happen that way. So for a stretch of time, nobody was entirely sure what they were looking at or how to interpret it. Eventually, as more data came in, the picture became undeniable. Voyager 1 had crossed the heliopause, the outer edge of the bubble blown outward by our sun's solar wind, and had entered true interstellar space, the vast region that exists between stars, not just a distant part of our solar system, actual interstellar space. It marked the first time in human history that anything built by our hands had left the sun's immediate neighborhood entirely and kept going. Stop and actually think about what that means. Every human being who has ever lived, every war, every love story, every single sunrise anyone has ever watched from any point in history happened entirely inside the bubble that Voyager 1 flew straight out of. It is now, quite literally, more alone than anything else our species has ever created. The second major twist came a full decade later, in 2022, and this one was far less awe-inspiring and far more unsettling. Voyager 1 began sending back telemetry, the routine housekeeping data that tells engineers exactly how the spacecraft's own systems are functioning, that made absolutely no sense. It wasn't corrupted static, and it wasn't blank silence, it was simply wrong. Random strings of numbers that didn't correspond to any known valid configuration of the spacecraft. Strangely, the spacecraft itself still seemed to be working fine underneath it all. It was still receiving commands from Earth, still keeping its antenna pointed home. But the status reports coming back looked almost like gibberish, as if a narrator who had spoken clearly and reliably for 45 straight years had suddenly, inexplicably started speaking in riddles. It took engineers months of painstaking detective work, sifting through old schematics and decades-old documentation, to finally trace the problem to the spacecraft's attitude articulation and control system, the very system responsible for keeping Voyager's antenna aimed precisely at Earth. That system had started quietly routing its data through a component that, unbeknownst to anyone, had actually failed years earlier. This should matter to you personally, because it's a preview of something every complex system eventually faces. A machine that still mostly works, but starts breaking in ways nobody predicted, forcing the people responsible to solve it with almost no direct information and an enormous, unforgiving distance standing between them and the problem. Real quick, if a 50-year-old spacecraft quietly solving its own self-inflicted identity crisis from 15 billion miles away doesn't deserve a like, I honestly don't know what does. Drop a comment too, because I want to know which part of this story is hardest for you to wrap your head around, since I'm still not sure I've fully processed some of it myself. The third twist is the one that actually caused the terrifying signal moment people started talking about. In November 2023, Voyager 1 effectively went silent, not completely dead, but functionally useless. It kept sending a steady radio signal back to Earth, proving it was technically still alive, but that signal carried absolutely no usable data, no science readings, no engineering status. Just a bare carrier wave, like a phone that rings and connects, but delivers nothing but static once you actually pick it up. For nearly 5 straight months, NASA's engineering team genuinely did not know whether they would ever receive real, meaningful data from Voyager 1 again. The root cause eventually turned out to be a single corrupted chip inside the flight data system, one of the spacecraft's onboard computers, responsible for packaging science and engineering data before it gets transmitted home. One chip, out of thousands of components, had failed, and it happened to be storing a small but essential piece of code that made the entire data packaging process function at all. Losing that one chip broke the whole chain downstream of it. Here's what makes this genuinely nerve-wracking to sit with. Engineers couldn't just drive out and swap the part. Nobody can. Every single command sent from Earth takes over 22 hours just to arrive, and any response takes another 22 hours to come back. That means one test, just to see whether a proposed fix actually worked, takes nearly 2 full days round trip, with no way to speed it up. And the team working this problem was troubleshooting an assembly language program, a coding style most modern software engineers have genuinely never encountered, using documentation that in some cases existed only on paper, tucked away in old filing cabinets, because it predated searchable digital databases entirely. Eventually, the team landed on a workaround. They relocated the affected code into different, still healthy sections of memory, splitting it carefully across multiple locations throughout the spacecraft's aging systems, essentially patching a 50-year-old operating system by remote control from across the solar system, with no backup plan if the attempt failed outright. When it finally worked, in April of 2024, it wasn't just a technical win worth a headline. It was the difference between Voyager 1 remaining a functioning scientific mission or quietly becoming permanent space debris, still flying, still transmitting a signal, forever, that nobody on Earth would ever again be able to understand. Because here's the unsettling part of that alternate outcome. If the fix hadn't worked, Voyager wouldn't have died in any dramatic, cinematic sense. It would have simply kept flying, kept transmitting that same hollow, meaningless carrier signal, endlessly, with nobody left able to read a single word of whatever it was still trying to tell us. A ghost ship, forever calling home, into a void that could no longer understand its language. That brings us to the human side of this whole story, because it's easy to get lost talking about chips and data streams and forget that actual people lived through every second of this crisis. Suzanne Dodd, the project manager for the Voyager mission at NASA's Jet Propulsion Laboratory, has worked on and off with this project across decades of her career. When the fix finally worked and real engineering data started flowing back in again, she didn't celebrate it like some kind of dramatic scientific breakthrough. She talked, instead, about sheer relief. In her own words, describing that moment, "We would love to get more science data, but honestly, just to get the engineering data back and know the spacecraft is okay, after struggling for months to find a solution, is a really big deal. That is not the language of triumph. That is the language of someone who spent months genuinely unsure whether they were about to lose something completely irreplaceable. Some of the younger engineers currently working on Voyager weren't even alive when it launched. They are learning outdated, decades-old programming languages specifically to keep this one spacecraft functioning, studying dusty manuals almost like archaeologists, piecing together instructions from a lost civilization, because most of the people who originally wrote that code have long since retired or passed away. Every single fix is a genuine gamble across a communication gap wider than anything else in human history, sending your very best guess out into total darkness, and then waiting almost 2 full days just to find out whether that guess was right. Which brings us to right now, this year, because this isn't a story that quietly wrapped up back in 2024. Voyager 1's power supply is still fading, and it will keep fading for the rest of its existence. It runs on a radioisotope thermoelectric generator, essentially decaying plutonium converted directly into usable electricity, and that power source loses roughly 4 watts of output every single year, without exception. It isn't dying suddenly, in one dramatic moment. It's dying gradually, predictably, almost like a candle burning down in impossibly slow motion, visible only if you're watching closely across years and years. So NASA has been forced to make brutal, deliberate choices, switching off individual instruments that are still working perfectly fine, not because they're broken, but purely because there simply isn't enough electrical power left to run everything at once anymore. In 2025, engineers made the difficult call to power down Voyager 1's cosmic ray subsystem instrument, a device that had been faithfully measuring radiation levels since the 1970s, without interruption, specifically in order to stretch out the spacecraft's remaining life and keep its most essential systems alive just a little bit longer. Sit with that decision for a moment. Somewhere in a control room on Earth, a small team of people had to choose which specific piece of a 50-year scientific legacy to permanently switch off first, fully knowing there is no undo button, ever, for a decision made 15 billion miles from home. And this is all happening while Voyager 1 is still, remarkably, doing meaningful science. It's still out there quietly listening to the interstellar medium, the extremely thin soup of charged particles and plasma that exists in the space between stars, and in recent years its plasma wave instrument picked up something almost hauntingly poetic, a persistent, steady hum of interstellar gas gently vibrating around the spacecraft, a sound scientists describe as unlike anything ever measured before, a kind of ambient background tone from the space between stars that simply had never been heard by anyone until Voyager 1 finally flew far enough away to hear it for the first time. NASA's own projections give us one number worth genuinely sitting with. Engineers currently estimate that by around the year 2036, Voyager 1 will no longer have enough electrical power available to operate even a single scientific instrument, or to keep its critical systems warm enough to continue functioning at all. Not possibly if things go badly. That is the trajectory we are already locked onto, barring some unforeseen failure that ends things even sooner than expected. For the very first time in the entire history of spaceflight, we can look at a calendar and see, roughly, the exact year that a 59-year-old, one-of-a-kind conversation with humanity's most distant creation will finally, permanently, go quiet. And once that moment actually arrives, Voyager 1 doesn't stop moving. It doesn't fall out of the sky, because there's no sky left to fall through out there, there's no atmosphere to burn it up, and no gravity well left strong enough to pull it back home. It simply keeps drifting, silently, forever, still carrying that iconic golden record, etched with sounds and images meant to represent all of Earth. Whale songs, spoken greetings in 55 different human languages, the sound of an actual human heartbeat, and Chuck Berry's Johnny B. Good. That golden record is a message built for absolutely anyone, or anything, that might one day encounter it. Deliberately sealed and coated in a thin layer of uranium-238 so that any hypothetical civilization that finds it could actually calculate, from the radioactive decay alone, exactly how long ago it was launched from Earth. Zoom out for a second, because this entire story is bigger than one aging spacecraft. Humanity has existed for roughly 300,000 years, and for almost all of that staggering length of time, our entire species was confined to a single small blue planet. And for the tiniest possible sliver of that history, less than 50 years, barely a heartbeat by comparison, we have had something built by our own hands, carrying a small piece of our story, physically cross the boundary of our entire solar system and step into the open space between stars. Voyager 1 isn't just a scientific instrument anymore, not really. It has quietly become a kind of proof of concept for something almost spiritual, that a species fully capable of war, disaster, and pettiness is somehow also capable of building something so precise, so resilient, that it can whisper back to us across 15 billion miles of empty darkness for half a century straight, and that we in turn can still choose, again and again, generation after generation of engineers, to keep listening. But here's what absolutely nobody can answer. Not NASA, not any scientist alive on Earth today. What actually happens to Voyager 1 after it finally goes silent for good? It will keep flying indefinitely, drifting through a galaxy that is itself still moving, still shifting, passing by stars that we've only just recently begun studying in any real detail. In roughly 40,000 years, current projections suggest it will drift within about 1.6 light-years of a distant star called Gliese 445, meaning it will actually be closer to that unfamiliar star than it currently is to our own sun. Will it still be structurally intact by then? Will it keep drifting silently for millions of years, quietly outlasting our sun, outlasting the Earth itself, outlasting every trace of the civilization that built it? Will anything, anywhere, in the entire unimaginable vastness of the universe ever actually find that golden record and understand even a fraction of what it was meant to say? Nobody knows. Nobody can know, not with any of the science we currently have. That question simply doesn't come with an expiration date attached to it, and it might genuinely never get answered, not in your lifetime, not in humanity's entire lifetime, maybe not ever, by anyone. If this story hit you the way it hit me while researching it, do me a favor and go ahead and subscribe, because there's a lot more where this one came from. Turn on notifications so you don't accidentally miss the next upload. Drop a comment down below and tell me what single sound or message you'd personally want to add to that golden record if you had the chance. Share this video with someone who genuinely needs the reminder that we, as a species, are capable of building things that quietly outlast us. And next time, we're heading even farther out, into the story of the spacecraft humanity built specifically to leave the entire galaxy behind, and the strange, unexpected thing it found on its way out that absolutely nobody saw coming.